Let's continue our topic. We were discussing about linear programming, objective function, constraints, etc. And now, if the constraints a11 x1 plus a12 x2 etc. a1n xn is of the type less than or equal to b1 or greater than or equal to b1, then how you can convert this less than or equal to equal to sign. Okay, so for that purpose what we do is we add a term, means if it is less than or equal to type, we add a term with this constraint. Say if I am adding an s1, a non-negative number to the left side, then the right side will become of the type equal to type. Okay, so for example, suppose you have an equation or a constraint 2x1 plus 3x2 is less than or equal to 2. Then I can make this less than or equal to equal sign by putting a term, say s1, by adding a term s1 this one, so that this is equal to 2. Say for example, if I say 3 plus 4 is less than say 8. Obviously 3 plus 4 7 is less than 8. Then how can I make this less than sign to equal sign? By adding a term 1 here. Okay, 3 plus 4 plus 1 I have added here, then this less than symbol is changed to equal to sign. Then the number so added, we call that as slack variable. Slack variable. Okay, so if it is less than or equal to type, we add a non-negative number to the right side and makes it equal to sign. Okay, similarly, if it is say 2x1 plus 3x2 is greater than or equal to 2, if it is of greater than or equal to type, then we subtract a non-negative number from the left side, so that say s1 is subtracted, so that the right side is equal to. Say for example, if I say 5 plus 2, 7 is greater than say 7 is greater than say 6. Okay, so 7 is greater than 6 we know. Now how can I convert this greater than symbol to equal sign? By subtracting some term from here. So when I subtract 1 from here, this greater than sign will be changed to equal to sign. So this number what you are subtracting, this is called as here, we call it as the surplus, means that term here, this one is extra here, so that I am subtracting, so that is called as surplus variable, or you can say this as negative slack variable. Okay, then to make less than or equal to sign to equal sign, you are adding some term, non-negative term, and to make greater than or equal to symbol to equal sign, you are subtracting a non-negative term. Now any solution which satisfies the non-negativity condition, that is all the and whatever non-negativity conditions are given, say for example, this is a non-negativity conditions, set of values which satisfies this non-negativity restrictions, we call that as feasible solution. Okay, we call that as feasible solution, means all the set of values, suppose x1 and x2, you are getting certain value, and x1 and x2, if that satisfies this condition, then that solution we called as feasible solution. Now any solution which maximizes or minimizes the objective function, so the objective function means z equal to c1x1 plus c2x2 plus etc. cnxn form, then we call this as, means any solution which maximizes or minimizes this one, you call this that as optimal solution. Okay, so if you are getting a maximum value after putting x1 x2 etc., then that is a maximized value, objective maximum value of the objective function you are getting, or if you are getting a minimum value, then we call that as z minimum, and in short you call that as optimal solution. Okay, so now we will discuss some standard forms of this LPP. So standard form of LPP. So in your exam you may have 5 marks question on this. So standard form of LPP. So here standard form of LPP, first conditions, if suppose I am given a question, maximize z is equal to c1 x1 plus c2 x2 plus etc. plus cn xn is given, and here subject to the conditions or the subject to the constraints, restrictions, a11 x1 plus a12 x2 plus etc. plus a1n xn is less than or equal to b1 and so on. Okay, so certain conditions are given and some equation to maximize it is given. Okay, then in a standard form, 2-3 conditions are there. Here the problem will be always to maximize. Your question will be always maximize, means maximize z is equal to like that. Now suppose it is given as minimize. Now question is minimize z is equal to say 2x1 plus 3x2. Okay, then this minimize problem should be converted to a maximization problem by putting or by multiplying this with minus 1. So this is a minimization problem. I have to convert that into a maximization problem to become a standard form. Okay, so to write the standard form of an LPP, the question means the objective function should be of the form maximization type. Okay, if it is minimized, then I am multiplying this with minus 1, so this becomes, it will become maximize minus z, negative z equal to negative 2x1 minus negative 3x2. Okay, so this is the first condition, means the objective function should be of maximization type. Now if the objective function is of minimization type, what we should have to do, it should be converted to maximize form by multiplying throughout by minus 1. Okay, minus 1 you need to multiply. Now the second condition is all the constraints are expressed in the form of equations. That is, the non-negativity restrictions will be obviously greater than or equal to 0 form, but all the constraints like a11, this type of constraints which is given there, that should be of equal to sign. Okay, so what we have to do is, if it is given as less than or equal to type, you have to, suppose it is given, constraints are given, say x1 plus 2x2 is less than or equal to say 5. This is a constraint given. Then to be in the standard form, what you have to do is, here this is to be converted to equal sign. So what we have to do there, you have to put some slack variable. So 2x2 plus say s1 equal to 5. So when you put s1 here, corresponding change in the objective function also will be there. That while doing the problem I will tell you that. So when you are adding s1 here, the objective function means z equal to whatever it is given, that also will be added with these terms. Okay, now if it is of say x1 minus 3x2 is greater than or equal to 7, this form. If the constraints is of this form, that is greater than or equal to form, you have to convert that into equal to sign by what to do? By subtracting this any constraint, say s1. If I put s1 here, I am putting say s2 here. So by subtracting a variable here, so that this will become equal to type. So that is the second condition, that is in a standard form of an LPP, the constraints, all the constraints are expressed in the form of equations. So be careful, except the non-negative restrictions. Non-negative restriction means at the end of that one it will be given say xi or x1, x2 etc. These are greater than or equal to 0. This will be as it is. These are non-negativity conditions. Okay. Then the third is the right side RHS of all constraints are non-negative, means the right side whatever you are getting should be positive. Okay, that should be non-negative, means greater than or equal to 0, that is non-negativity. So if the RHS is negative, suppose you are given x1 minus 2x2 say equal to minus 3. This is one condition is given, suppose, then this should not be negative 3. You have to convert this into positive by multiplying this throughout by negative sign. So minus 2 minus x1 plus 2x2 equal to 3. So this is the third condition. So the right hand side of all constraints, only the constraints are non-negative. That is, if the right hand side is negative, multiply it with minus 1 and make it positive. Okay, and all the decision variables means all this x1, x2, etc., xn, and all these like variables s1, s2, etc., xn, they are always non-negative. They will be always non-negative. Okay, so these are the 4 conditions. Summing up again, I am telling you, that is standard form of an LPP. The question will be of the form maximization type. If it is, that is, the objective function should be of maximization type. If the objective function is of minimization type, it should be multiplied with a minus 1 and then convert that into maximization form. Second is, all the constraints should be in the form of equations. If they are of less than or equal to or greater than or equal to type, convert that into equal sign by adding slack variables or surplus variables. Then all the RHS of constraints should be positive. If it is negative, multiply throughout by a negative sign and make it positive. And fourth is, all the decision variables and slack variables are of non-negative type. Now I will tell you how to convert or how to write a standard problem. Before that, a little more thing, that is some types of solution. This you should know while doing a problem. So some types of solution, that while doing an LPP, you will get 2-3 types of solution. First is basic solution. Basic solution means a solution obtained by setting some, say for in simple language, if I say, suppose you have 4 variables, x1, x2, x3, x4, and you are given 2 constraints, means 4 variables are given in the objective function, and suppose you are given 2 constraints only, means 2 equations, 2 conditions only given. Then 4 unknowns and 2 equations, it is not possible to solve that equation. So what we have to do is, if there are 4 unknowns, you must have 4 equations. So when it is not there, what we will do here, we will keep any 2 variables as 0. Okay, any 2 as 0 and you will find the other 2. Okay, then a solution obtained by setting any n variables out of m plus n variables equal to 0 and solving for the remaining variables, you are getting some solution. And then that solution you get as, or you call it as basic solution. Suppose x1, x2, x3, x4 are there and you are given 2 equations only. So I am keeping x1, x2 equal to 0. Then I will get the solution for x3 and x4. Okay, then that is called as the basic solution. Okay, then now if this basic solution satisfies non-negativity restrictions, means if this basic solution what I am getting is greater than or equal to 0, means if it satisfies a non-negativity solution, then you call it as a basic feasible solution. Okay, so basic solution means keeping some variables, setting any n variables out of m plus n variables equal to 0 and you are solving for the other 2 variables or other m variables, then you call that as a basic solution. And the 2 variables I told because I consider this four terms here. Okay, 4 variables here. So, and secondly, if the basic solution so obtained satisfies the non-negativity condition, then that is called as basic feasible solution. Now here all the m values of this basic variables, whatever you are getting the basic variables, they are positive, and the basic feasible solution, then that basic feasible solution means if the answer what you are getting for the variables, if they are positive, then this basic feasible solution is called as non-degenerate basic feasible solution. Okay, that is the basic feasible solution. When do we say? Means this solution if you are getting in that are positive, and then or if this satisfies the non-negativity condition, then we call that as basic feasible solution. Now if all the basic variables, if all the basic variables so obtained, then this basic feasible solution is called as non-degenerate basic feasible solution. Okay, then in the basic feasible solution, if so suppose I am considering this x3 and x4. So while solving this x3 x4, suppose this one of these values is 0 or 2, can be whatever the number you are finding out. So if in the basic feasible solution obtained one or more values of m basic variables are 0, then this basic feasible solution is degenerate basic feasible solution. Simple words, if you say answer, whatever answer you are getting, if there is no 0 in that, whatever answer of this basic variables what you are getting, okay, if there are no zeros, then that is non-degenerate basic feasible solution. If there are some zeros in that answer, means say for example x3 x4 I am getting some zeros in that one, then that will be degenerate basic feasible solution. Okay, so that is a basic concept of LPP and the various types of solution. Now I am going to convert this LPP into standard problem. Convert the following LPP in the standard form. So here it is given, maximize is given, maximize it is given only. So first condition, it is maximize, it is given already. Z is 3x1 plus 5x2 subject to the conditions. So standard form, first thing is the problem should be of maximization type, that is done. Second is the constraints should be of equal to type. So 3x1 plus 2x2 equal to, I have to write equal to 15, this is less than or equal to. Okay, so I will write plus s1. Okay, and second one is 2x1 plus 5x2, it is greater than or equal to 12. I have to write here this is equal to 12. So I will write here say minus s2. Okay, and here third condition, non-negativity x1, x2 is greater than or equal to 0. Non-negativity condition also you wrote, and s1, s2, that also should be non-negative, means greater than or equal to 0. So that is standard form of an LPP, means we introduced the slack variables there and then we did so. Okay, so now here to make it more clear, now you have added here, subtracted s2 from there. So in the standard, I mean in the objective function also you have to write here plus 0 s1 plus 0 s2. Okay, and here also s1 plus what I will write here 0 s2, and here s2 is subtracted. So what you have to do there, you have to put an s1 here, 0 s1. Okay, so 3x1 plus 2x2 plus s1 I added. Now here again x1 x2 s1 s2, 4 variables are there. So to make it a more neat one, we are putting 3x1 plus 2x2 plus s1 plus 0 s2 equal to 15, and this 2x1 plus 5x2 plus 0 s1 minus s2 equal to 12, and in the objective function also s1 s2. This is the non-negativity condition. So this is the standard form. Okay, now convert this into a standard form. See, minimize it is. So minimization type it is given. So I have to convert this into maximization type. So I will write maximize what we have done. So already discussed, if it is minimized, I will multiply this with a negative sign, minus 1. So minus 1 into z, here minus 1 into 3x1. So 3x1 minus 2x2 plus x3. Okay, subject to conditions. x1 minus 3x2 plus 2x3. Now here greater than or equal to 6. Greater than or equal to minus 6 it is. Now again here the right side should not be negative. So first of all I will put slack variable here or surplus variable here. I mean negative slack variable. So it is greater than or equal to. So what I have to do here, I will put here equal to sign. Okay, greater than or equal to. So actually we need to subtract S1 from there. So I put equal to minus 6 here. But the right side should be of positive sign. So what I have to do here, throughout I will put negative sign, multiply by minus 1. So minus 1 into x1 minus 3x into minus 1. This will become what? This will change to minus. You should not paint like that. You should do it properly. And this will be plus S1. Okay. I have left a little space here for some other purpose. So equal to 6. Now second condition is 3x1 plus 4x3. Here x2 is there. Here there is no x2. So I will just put 0 x2 plus 4x3 equal to 3. Equal to 3 means what I have to do, plus S2. S2 I have added here, equal to 3. Okay. And third one, minus 3x1 plus 5x2 plus, so S1 is done, S2 is done. Now I will add S3 with this, plus S3 is equal to 4. Okay. Now here S1, S2, S3 is there. So here also I will put 0 S1 plus 0 S2 plus 0 S3, or minus 0 S1 minus 0 S2 minus 0 S3, that doesn't matter. So you can write it anyway. Now here S1 plus 0 S2 plus 0 S3. Okay. And here 0 S1 plus S2 plus 0 S3, and here also 0 S1 plus 0 S2 plus S3 equal to 4. Now here here again one more problem is there, that is here in the question if you are seeing, you can see x1 x2 greater than or equal to 0 and x3 is unrestricted. Now what is this unrestricted means? X3 is unrestricted means x3 can take any value, any non-negative value. So here what normally we do is, suppose I am taking x3 equal to some x3 dash minus x3 2 dash. Okay, x3 2 dash. Just I am putting to make sure that this is positive, this is not negative. Now what is this unrestricted condition? Suppose you have x3 is equal to 8. So sorry, x3 equal to say 5, simple number will take x3 equal to 5. Now unrestricted means you can choose two numbers such that their difference is 5. So suppose I am taking x3 dash is 8 and x3 2 dash is 3. So x3 dash minus x3 2 dash will be 8 minus 3, that is 5. You have to choose x3 dash and x3 2 dash such that their difference is positive. Okay. So this is unrestricted condition means. Now you can take, this is not unique, these two numbers are not unique. Suppose I am taking x3 dash is 108 and x3 2 dash is 103, that also I can take. So this numbers, this whatever unrestricted condition, whatever it is given, that is not unique. You can take any two positive values such that their difference is always positive. So that is the meaning of unrestricted. Okay, any pair that can be considered so that this x3 is greater than or equal to 0. That is the meaning of unrestricted conditions. Okay, so here what we have to do is, now here it is 4x3 is given. Okay, so that 4x3 will be, I have to replace this 4x3 this 4x3 will be replaced by 4 instead of x3. I will write x3 dash minus x3 2 dash. Okay, so in a total this equation will be 3x1 plus 0x2 plus 4x3 dash minus 4x3 2 dash plus 0s1 plus s2 plus 0 S3 equal to 3. Okay, so this is the standard form of LPP, and at the end you have to write there x1 x2 is greater than or equal to 0, and obviously what x3 dash x3 2 dash x3 dash and x3 2 dash, then what s1 s2 s3 all these are greater than or equal to 0, means non-negativity condition. So this is a way to write standard form.